This video looks into the concept of power factor in AC circuit theory. The general equation for calculating power is P is equal to I by V, where I is the current and V is the voltage. For many real circuits, however, this will not give the actual amount of power that is consumed. The reason for this is that most circuits contain a combination of both resistive elements that dissipate power and reactive elements that only appear to dissipate power. Hence, the total amount of power supplied to a circuit is known as the apparent power, a combination of both real and reactive power. Now, to understand the concept of power factor, it is important to first acknowledge the relationship of Ohm's law that V is equal to I by Z, where I is the current and Z is the impedance. Impedance is the resulting vector of the resistance and reactance of a circuit. The resistance vector caused by resistors is on the real axis, and the reactance vector caused by inductors and capacitors is on the complex axis. Z can be calculated by applying Pythagoras' theorem to the right-hand triangle that the three vectors form. So I mentioned earlier that reactive elements only appear to dissipate energy. To further explain this, unlike resistors that dissipate energy through work, reactive elements store energy in one half of the cycle, then return it back to the network in the other half, thus still producing impedance but not consuming any power. By substituting the equation derived from Ohm's law into the general power equation, we can say that P is equal to I squared by Z. Using this new definition, each vector of the impedance triangle can be multiplied by I squared to transform it into a power triangle. The three vectors of a power triangle represent the real, reactive, and apparent power values. This brings us to the definition of power factor, which is the ratio between the real power and apparent power. We can calculate the power factor by taking the cosine of the angle theta between the real and apparent power vectors in a power triangle. This angle theta is actually the phase difference between the voltage and current waveforms within a circuit. When dealing with power factor, you will likely come across the terms leading and lagging power factors. In inductive circuits, current lags voltage, and hence theta is positive. In capacitive circuits, current leads voltage, and hence theta is negative. The smaller that the phase difference becomes, the closer the power factor becomes to plus or minus 1, which is a purely resistive circuit that dissipates 100% of the supplied power. The larger that the phase difference becomes, with a maximum of plus or minus 90 degrees, the closer the power factor becomes to 0, which is a purely reactive circuit that dissipates none of the supplied power. I hope this helps a bit, and thanks for listening.